Two small iron particles, each of mass 280 mg, are placed at a distance 10 centimeter apart. If 0.01% of the electrons of one particle are transferred to the other, find the electric force between them. Given Fe, atomic number 26, and atomic weight 56. So here, let's find out the number of atoms present in 280 mg of iron, and after that we will calculate the number of electrons. So 56 gram Fe contains 6.022 into 10 to the power 23 atoms. So 1 gram Fe will contain 6.022 into 10 to the power 23 divided by 56. Here we are given 250 milligram. So 250 into 10 to the power minus 3 gram will contain 250 into 10 to the power minus 3 into 6.022 into 10 to the power 23 divided by 56 atom. Now, here, each atom of Fe contributes 26 electrons. So, number of electrons we can find by multiplying this term by 26. This is number of electrons. Now, in our question, it is given that only 0.01% of the electrons of this will contribute in calculation of the force. So here we take 0.01% of the same. So we write 0.01 divided by 100. So these things you can do separately. So here we will get number of electrons equal to. So we can summarize this. So after calculation, we will get it around 7.8 times 10 to the power 18 electrons. Now, let's calculate the total charge. So we know that on each electron, the charge is 1.6 into 10 to the power minus 19 coulomb. So total charge Q will be equal to Ne. So if we multiply this 7.8 multiplied by 10 to the power 18 times electronic charge, 1.6 into 10 to the power minus 19 coulomb. So this will become around 1.2 coulomb. So we have got charge. Now there are two charges, Q1 and Q2. Both are equal to this, and separation is 10 centimeter. So now we can easily calculate the force. So F will be equal to 9 into 10 to the power 9 Coulomb's law into product of the two charges, 1.2 into 1.2 divided by separation squared. Separation is 10 centimeters, so 0.1 square. So this will come out to be 1.3 into 10 to the power 13. 10 to the power 12 Newton. Now let's go to next question. So next question is, a charge Q is to be divided on two objects. What should be the values of charge on the two objects so that the force between them can be maximum? So suppose charge is divided into two parts. One charge is small q, another is q minus q. Here small q is variable. So suppose the two charges are kept at separation small d. So this is small q, this is capital Q minus small q. We find the force F equal to 1 upon 4 pi epsilon naught times small q into capital Q minus small q divided by d square. Here, small q is variable. So in order to get maximum force, we can differentiate it with respect to small q. So df divided by dq, 1 upon 4 pi epsilon naught d square. And if we differentiate it by using product rule, so this will become 1 times q minus q, then plus, keeping q intact, we differentiate it. So q is constant, this will become 0, and this will give minus 1. Now, to get maximum force, df upon dq must be 0. So if we make it 0, we get q minus 2q equal to 0. So we can say small q is half of q. So if both charges are q by 2, then force will be maximum. Now let's go to next question. Next question says two particles each having a mass of 5 gram and charge 10 power minus 7 coulomb stay in limiting equilibrium on a horizontal table with a separation of 10 centimeter. So suppose one particle is here, another particle is here, and this has charge 10 to the power minus 7 coulomb. This has charge 10 power minus 7 coulomb. So there will be force of repulsion. So in this direction, the force will act. Now, to counterbalance this force, there is a friction. If friction is equal to repulsive force, in that case, the particles or masses will not move. So repulsive force F is given by mu mg, where mu is coefficient of friction. And here in our question, we have to find out mu. So we write this value here, mu times m. M is 5 gram, that is 5 into 10 to the power minus 3 into g. G we can take 9.8 equal to repulsive force. So this is 9 into 10 to the power 9 into product of two charges, 10 power minus 14 divided by separation. Here separation is given as 10 centimeter. So 0.1 square. We simplify. So mu equal to, this will become 9 into 10 to the power minus 5. From here it will give 10 power 2 positive, because 0.1 is 1 upon 10, 1 upon, and divided by 5 into 10 to the power minus 3 into 9.8. Now we can evaluate it. So it will become 0.009 divided by 0.049, which will be equal to mu equal to 0.18. So this is coefficient of friction. Thank you for watching.